Okay, we have another integral today. This one's from Caltech Math Meet 2025 Finals 33. We have the integral of x squared minus 1 over x to the fourth plus 1 dx. Okay, for this one I had a specific method in mind. What I wanted to do was an old trick that I haven't done in a while. It's just multiply by 1, multiplying in 1 over x squared over 1 over x squared. The reason for this is because initially it's not really set up for a u substitution. There's not really a good way to factor it. So it's kind of a problem, but with this, I think it's going to help us out. So when we multiply in, the numerator becomes 1 minus 1 over x squared. And then in the denominator, multiplying these, we get x squared plus 1 over x squared. Now for this thing here, there's two ways to factor it that I know of. You could do x minus 1 over x and square that, or you could do x plus 1 over x and square this. The reason I want this way is because if I do a u substitution, what's going to happen is it's going to create the minus sign. So I want this to have the opposite sign as this in the numerator. But before we do it, notice one thing. When we square this out, we get x squared plus 1 over x squared. Then the middle terms create a plus 2 that we don't have there. So in order that I don't change it, we'll write a minus 2. So now this is the same as this. So what I can do is take this and we'll plug it into the denominator and set this up. And so now I'll go ahead and substitute. Let me get a little space over here. So what I want this to be my u. So we do u equals x plus 1 over x. Take a derivative. We get derivative, that's going to be 1. This becomes minus 1 over x squared dx. So we're in good shape because our du is going to be the whole numerator right here. Go ahead, what we end up with is going to be du over u squared. For minus 2, let's set this up so I can write this as minus square root of 2 all squared. And then here what I like to do is use a formula. Now there's two ways. I could do it as minus 1 over square root of 2 using this formula and do it as inverse tanh of just u over square root of 2. And I probably prefer it this way just because it's more compact, but Caltech has it in terms of natural log, so let's do it that way instead. And I think that way might be more common. I'm not really sure, but we'll just do it their way to I think the natural log might be more common, so we'll just go along with that just to fit in. So then we're going to have, it becomes 1/2. It's pretty similar, so we're still going to have 1 over this. So we have 1 over 2 square root of 2. Natural log, it's going to be u minus square root of 2 over u plus square root of 2. But then go ahead and back substitute on it. It's going to get a little bit messy here. So we're going to have the constant out front. Let's see if I can squeeze it in over here. So we're going to have x plus 1 over x minus square root of 2, x plus 1 over x plus square root of 2. And now we could leave it, but let's try to clean it up a little bit. I can multiply in by 1, multiplying in by x over x, just to clear that out of the denominator there. So when we do it, let's see what happens. We get 1 over 2 square root of 2, natural log. Then it's going to become x squared. I'm going to reorder it and do it minus square root of 2x plus 1 over x squared plus square root of 2x plus 1, add a plus c, and that's it. Okay, so there you go. The u substitution works out pretty nicely in this case. I'm not even sure what other methods there are. I didn't think about it. So it looks like other ways could be messy, but I didn't try it, so I can't really comment on that. So no comment. Thanks everyone for watching. Have a good day.